Hello everyone, and welcome back to the channel. We're diving into a super interesting trending piece from the archives. It's a look at how we can make searching for videos, actually work the way we think it should. Let's get this pulled up. Right, so the paper is called Towards Universal Video Retrieval. Generalizing Video Embedding via Synthesized Multimodal PLM Curriculum. The tool is Point per 15.27,571 of them. It's long. Okay, so let's break this down. What's the big problem this paper is trying to solve? Well, think about how you search for videos right now. You type some words into a search bar and you get some results. It's okay, but it's also kind of basic. The authors here say the whole system is structurally misaligned. That's a fancy way of saying that the way we test these AI models is way too narrow. We give them a simple task, like finding a video from a short text description. When they do well, we say great job. But in the real world, we want to do so much more, right? You might want to find a video using a picture and some text. Or maybe you want to find a tiny moment in a really long movie. Current models, they just fall apart. They're like a one-track pony that's been trained for one specific race. But they can't do anything else. This paper wants to build a decathlete, a model that's good at everything. So, how did they do it? They came up with a really clever three-part plan. It's like they're building a whole new ecosystem for video search. First, they created a new benchmark, a new set of tests. They call it the Universal Video Retrieval Benchmark, or UVRB. It's not just one test. It's a suite of 16 different datasets that check if a model can handle all sorts of things, like long video super specific details, even word queries that mix images and text. This benchmark doesn't just give a score, it diagnoses exactly where a model is weak. Second, once they had this diagnostic tool, they saw where all the gaps were. There just wasn't enough good data out there to truly universal model. So they made their own. They developed a smart pipeline called V-SynFlow to automatically generate 1.55 million high-quality training examples. It takes messy videos from the web and creates perfect, diverse queries for them. This new dataset is called the Universal Video Retrieval Dataset, or UVRD. With the right test and the right data, they needed the right training method. This is where it gets really cool. They created something called the modality pyramid. It's a curriculum for the AI model, which they call the General Video Embedder. Or think of it like teaching a kid. You don't start with calculus, right? You start with basic counting. The modality pyramid does the same thing for the AI. It first trains the model on foundational tasks, like understanding simple text and images. Once it masters those, it moves up a pyramid to more complex things, like understanding how actions unfold over time in a video, or how to combine information from an image and text. It's a bottom-up approach that builds knowledge progressively. Why did the video retrieval model break up with the image model? Because it felt like it was living in a static relationship. Did it? Static. Okay, tough crowd. Anyway, how does this compare to what we had before? Older models were often based on a technology called clip. They were pretty good that they had their limits. They often focused more on what objects were in a video, the spatial stuff, rather than what was actually happening over time, the temporal stuff. So they might see a dog and a ball in a video, but they wouldn't really get that the dog is chasing the ball. Newer models are based on multimodal large language models, or MOLs, which are much more powerful. The GAVE model in this paper is one of those. But even these powerful models were being held back by the old, narrow benchmarks. This paper's framework is what finally lets them reach their full potential. The results are pretty clear. They give the other 14 models out of the water, even giant ones with billions of parameters. It shows their data and training method made all the difference. So what does this mean for our everyday lives? This could totally change how we find and interact with video content. For example, imagine you're on a video platform. Instead of just typing, "cats playing piano," you could upload a picture of your own cat and type, find videos of cats that look like this one, doing something funny. That's a composed query mixing an image and text. And this technology is designed to handle it perfectly. Let's talk about some specific fields. First, information extraction and text summarization. A journalist could be sifting through hours of footage from a city council meeting. They could ask the system, show me all the clips where the mayor is talking about the new park project, while pointing at the specific blueprint, and then upload an image of the blueprint. The system would pull those exact moments, saving the journalist an incredible amount of time. Second, chatbots and dialogue systems. Let's say you're planning a vacation and talking to a travel chatbot, who could send it a picture of a beautiful, secluded beach and say, I want to find a resort with a beach that looks just like this, and show me video tours of the rooms. The Universal Retrieval model could understand that complex request and provide visually relevant results, making the whole experience much more helpful. And third, let's think about machine translation in a broader sense. This isn't about translating French to English. It's about translating a user's complex intent into the right video. The user's query, like find a sci-fi movie with the actors from this photo, that also involves a black hole, is a language of its own, mixing modalities. This system acts as a universal translator, understanding a mixed media language and finding a perfect video match. So to wrap it up, this paper isn't just about a slightly better search algorithm. It's a whole new way of thinking about the problem. By redesigning the evaluation, the data and the model training all at once, it created a path toward true universal video retrieval. It's a foundational step that could make our digital world a lot easier to navigate. Super cool stuff.